In the era of modern agriculture, each harvest season is no longer simply the sight of farmers working in the fields. It has become a vivid picture of the harmony between human intelligence and the power of technology. Massive machines, powered by automation systems and artificial intelligence, are completely transforming the way we produce food. In just a few hours, thousands of hectares of land, which is about tens of thousands of acres, can be harvested with almost absolute precision, something that once took weeks or even months of manual labor. This is not only a leap in productivity, but also undeniable proof that agriculture has stepped into a new era, faster, more precise, and on a scale never seen before. Let us explore how technology is redefining the concept of a harvest season and turning agriculture into a high-speed industry. Welcome to Florida, where endless orange groves stretch as far as the eye can see, painting a dazzling orange canvas under the tropical sun. In the middle of this landscape, modern technology is gradually replacing manual labor. Instead of wooden ladders and bamboo baskets from the old days, there now stand massive tree-shaking machines, powered by hydraulics, working with near-perfect precision. A mechanical arm grips the trunk of the tree, and within just a few seconds of powerful shaking, thousands of ripe oranges fall at once into a specially designed catching frame below. Each falling fruit is not a random accident, but the result of years of careful research, ensuring that the ripe oranges are harvested whole and unbruised. Immediately after, an automated conveyor system carries the fresh oranges upward, passing them through high-powered fans that blow away leaves, twigs, and any lingering dust. Layer after layer of clean, glossy oranges then tumble into large storage bins, ready for the next stage of their journey. In a single day, this system can harvest dozens of tons of oranges, which is about dozens of metric tons. That is tens or even hundreds of times more than what manual labor could achieve in the past. But more importantly, technology not only boosts productivity, but also preserves and even improves the quality of the crop. Because once the process is standardized and automated, the oranges that reach consumers are more consistent in size, cleaner in appearance, and fresher thanks to the shortened harvest time. Florida has long been famous worldwide for its pure orange juice. Those bright-colored bottles of juice, sweet, smooth, and rich in vitamin C that we often see on supermarket shelves, are the very result of this chain of processes. A portion of the oranges goes into processing plants, where cold pressing technology preserves their natural flavor and nutrients. The rest are carefully graded, packed into standard trays, and shipped straight to the fresh fruit export market. Each orange is not only an agricultural product, but also a symbol of the reputation and image of Florida itself. What makes Florida's orange harvesting technology a model for agriculture worldwide is the balance it strikes between industrial scale and respect for quality. In the past, during manual harvests, ensuring that thousands of oranges stayed equally fresh was almost impossible. But today, with the combination of precision mechanics, automation, and intelligent sorting systems, every orange leaving the grove carries the highest market value. Looking more broadly, this is not just the story of a single fruit. It reflects the inevitable trend of modern agriculture, producing on a large scale while still maintaining the care devoted to each product. Florida oranges, from the grove to the dining table, are a clear demonstration that technology is not simply about multiplying quantity, but also about defining the quality that ultimately matters. Behind every truckload of oranges is a seamless collaboration between human intelligence and machine power. It is the fruit of years of scientific research, the pride of Florida's farmers, and a statement that agriculture today has truly entered a new era, one where speed, precision, and quality coexist in every abundant harvest. Potatoes, the familiar tuber found in everyday meals, usually enter their harvest season from September to October, when the leaves and stems above the ground begin to wither, giving their remaining nutrients back to the tubers hidden beneath the soil. In the past, farmers had to dig each plant by hand with hoes and shovels, but today, technology has turned that heavy labor into a precise, fully mechanized process. Modern potato harvesters, with sharp blades, cut deep into the soil and gently lift entire clusters of potatoes to the surface. But the job does not stop there. Since potatoes come out covered with soil, sand, and tangled roots, they need to be cleaned right away. Vibrating sieves shake steadily, separating soil and weeds from the crop, allowing the golden brown potatoes to emerge clearly under the sunlight. This step is crucial to minimize bruising or breaking during the harvest. Right after leaving the ground, the flow of potatoes moves onto an automated conveyor system. Here, sorting takes place continuously. Those that meet the standards of size, firmness, and smooth surface are sent directly into storage bins. Meanwhile, diseased, misshapen, or damaged tubers are removed thanks to sensors and advanced filtering mechanisms. From a broader view, layer upon layer of potatoes runs along the belts, stacking together into a golden stream, steady and seemingly endless. This process saves thousands of hours of manual labor while greatly improving product quality. Each harvesting machine can process dozens of tons of potatoes per day, which is about dozens of metric tons, meeting the enormous demand of both the food processing and export industries. Germany, Poland, and many other European countries have fully embraced this technology, turning themselves into some of the world's leading potato suppliers. Millions of tons, or millions of metric tons, are harvested and distributed every year, serving a wide variety of purposes. Fresh potatoes in supermarkets, crispy fries, food starch, and even as a base ingredient for producing vodka. Behind those impressive numbers lies the precision of an entire technical system. Every link in the chain, from soil-cutting blades and vibrating sieves to sorting conveyors, is carefully designed to minimize crop damage. Even a small bruise can shorten storage life considerably. That is why technology not only raises productivity, but also directly determines the ability to preserve quality during transport and storage. Enormous cold storage facilities receive the potatoes immediately after leaving the fields, maintaining ideal temperature and humidity so that they can stay fresh for months. This seamless integration of mechanical harvesting, automated sorting, and scientific storage creates a closed value chain, bringing potatoes from farm to table with remarkable reliability. Potatoes have long been more than just a staple food. They are the foundation of an entire food industry. The crunchy snack packs, golden fries, and clear glasses of vodka all begin in the potato fields at harvest time. Each tuber lifted from the soil is the result of centuries of agricultural innovation, and today it stands as undeniable proof of how technology is reshaping the global food supply chain. From the vast fields of Europe to the modern processing plants, potatoes have gone beyond the limits of a simple food to become a symbol of industrial agriculture. And that journey, beginning with the hum of harvesting machines, is the most vivid illustration of human progress in transforming land and labor into lasting wealth and value. In Vietnam, as in many other Asian countries, shallots have long been an essential ingredient in family meals. When harvest season arrives, instead of hundreds of workers bending down to pull each plant by hand, farmers today can rely on specialized harvesting machines that act like a giant mechanical hand. Sharp blades cut gently through the soil at the roots, loosening the earth that holds the bulbs. Then the entire plant, from root to leaf, is lifted cleanly from the ground. The motion is quick, steady, and uniform, minimizing the chance of broken bulbs or damaged roots. Immediately afterward, the shallots pass through a mechanical brushing system combined with powerful streams of air, which remove the remaining soil and dust clinging to the bulbs and leaves. Each vibration, each gust of air, is carefully calibrated to clean thoroughly while preserving freshness. Once the initial cleaning is complete, the shallots are gathered into clusters and laid neatly in rows right on the field. This is the preparation for the drying process, an essential step to ensure firmness and to reduce spoilage during storage and transportation. Under the sun and wind, the outer skins gradually dry, forming a natural protective layer for the bulbs inside. From those long rows of shallots spread across the field, their distinctive fragrance begins to fill the air. Compared to traditional manual work, the introduction of harvesting machines has brought remarkable change. In the past, harvesting just a few hectares of shallots, which is about several acres, required dozens of workers laboring for days or even weeks. Now, in just a single morning, machines can complete multiple times that workload. Beyond saving time, this technology also significantly reduces post-harvest losses, since the bulbs remain intact and far less bruised during harvesting and cleaning. This chain of processes not only improves productivity, but also sets the foundation for higher product quality. Bundles of shallots, once dried and packaged, show striking uniformity, meeting the demands of both domestic consumption and export. For strict markets, the firmness of the bulbs, their naturally dried outer skins, and their concentrated flavor are crucial factors in increasing value. Behind every fresh bunch of shallots that reaches consumers lies the careful combination of centuries-old farming experience and the strength of modern technology. The harvesting machine is not just a piece of mechanized equipment, but a symbol of agriculture's transformation, from small-scale production heavily dependent on manual labor to a more professional model that saves resources and enhances quality. Unlike traditional deep plowing, which uses straight blades to flip over large chunks of soil, the disc plow operates with a system of continuously rotating circular blades. Each thick, slightly curved steel disc spins on its axis, creating a steady cutting and turning force. As the machine moves forward, it not only slices through the crop residues from the previous season, but also mixes them evenly with the soil, transforming them into a fertile organic layer for the next crop. The impact of the disc plow can be seen immediately. Instead of hardened, crusted soil or thick layers of leftover stubble, the field surface becomes soft, crumbly, and rich in nutrients. Each rotating disc scoops up roots, decayed leaves, and straw, grinding them into smaller pieces before burying them back into the soil. This process not only enhances fertility, but also reduces the need to burn residues, which often creates smoke and pollution, a clear environmental benefit of modern mechanized farming. Disc plows are particularly useful in preparing soil for a wide range of crops, from wetland rice to corn, potatoes, and short-term vegetables. In rice fields, post-harvest straw is mixed thoroughly into the soil, acting as natural green manure. In corn and vegetable plots, leftover stalks and stems are handled just as efficiently, returning essential nutrients for the next planting season. Thanks to this method, the soil is sustainably improved, dependence on chemical fertilizers is reduced, and its loose texture is maintained to support healthy root development. The advantages of disc plows are not only in soil quality, but also in speed. A medium-powered machine can process dozens of hectares per day, which is about dozens of acres, replacing the work of dozens of manual laborers. At the same time, the continuous rotation and efficient friction reduce fuel consumption compared to traditional deep plowing. As a result, farmers save both time and costs while ensuring long-term productivity. Across fields both large and small, disc plows are increasingly becoming the farmer's right hand. More than just a mechanized tool, they are proof of the powerful transformation in modern agriculture, where productivity, efficiency, and sustainability all come together. With every turn of the discs and every layer of loosened soil, a solid foundation is laid for a promising harvest season ahead. Across the vast cornfields of the United States and China, hybrid corn planters operate like an assembly line engineered with absolute precision. From the seed hopper mounted on the machine, kernels are fed into a distribution system, each one dropping exactly into its designated spot. A sliding wheel opens a narrow furrow. The seed is placed inside, and immediately a layer of fine soil is closed over and pressed firmly just enough to ensure both moisture retention and perfect contact between the seed and the earth. The defining feature of modern planters lies in their control technology. Integrated GPS systems and optical sensors monitor the spacing between kernels in every row. For each square meter of soil, which is about 10.7 square feet, the seeding density is calculated to be optimal, not too sparse, which would waste land, and not too dense, which would cause competition for nutrients. Thanks to this, once germination begins, the entire field grows in perfect alignment, reducing gaps and maximizing yield. Another key advantage of this technology is the reduction of seed loss. In the past, manual sowing often led to spillage or uneven distribution, which directly affected productivity. Now, every single hybrid kernel, carefully bred and selected for its superior traits, is used to its full potential. This is especially important because hybrid seeds carry high genetic potential, offering better disease resistance and higher yields compared to traditional varieties. With the support of precision planters, hybrid corn yields around the world are becoming more consistent and sustainable. This is not just another step in mechanization. It is the foundation of precision agriculture itself, where every seed is placed with the confidence that it will grow into a strong, healthy corn plant, helping to feed millions of people. Alongside large-scale pivot irrigation systems, many farms specializing in vegetables, melons, and grapes are turning to drip irrigation, a solution precise down to each individual plant. Across long rows of soil, narrow pipes are laid parallel along the crops. At every planting point, a drip emitter is installed to deliver just the right amount of water, drop by drop, directly to the root zone, soaking deeply without spreading outward. This seemingly simple principle brings extraordinary results. Compared to traditional flood or sprinkler irrigation, drip irrigation saves between 40 to 60% of water, which is about 40 to 60%. Water is no longer wasted through surface evaporation, nor does it run off to cause soil erosion. Every single drop is carefully measured, gradually seeping into the soil where the roots grow, ensuring that the plants always receive the moisture they need. Another crucial advantage is the ability to combine fertilizers with the water flow. Instead of scattering fertilizer manually across the field, soluble nutrients are delivered straight to the roots together with the irrigation. This way, fertilizer use is maximized, runoff is minimized, and pollution of soil and groundwater is reduced. This is the key reason drip irrigation has become the foundation of smart agriculture, where crops receive exactly what they need at exactly the right time. Thanks to this technology, many arid regions once thought impossible to cultivate have been revived. Israel is a prime example. From barren deserts, drip systems have transformed dry land into lush fields, turning the country into one of the world's leading exporters of high-quality produce. In India, the same solution has enabled millions of smallholder farmers facing severe water shortages to maintain stable yields across vast fields of cotton, vegetables, and grapes. Drip irrigation is more than just a method of watering. It is a symbol of precision, efficiency, and sustainability in modern agriculture. Each drop that falls not only nourishes the crops, but also sustains the hope of an agriculture that can thrive even under the harshest conditions. In the endless vineyards of California, specialized pruning machines move quietly along the rows, replacing the work of hundreds of human hands. High-speed rotating blades trim away excess branches with precision, each motion deliberate and exact, as if programmed to leave only what the vines truly need. As the tangled branches disappear, sunlight pours evenly through the canopy, fueling photosynthesis at full strength. The grapevines grow in perfect balance, producing clusters that are plump, uniform in size, and rich in flavor. What once depended on the skill and patience of workers is now guaranteed by precise mechanization. Labor efficiency has multiplied many times over. In the past, pruning dozens of hectares of vineyards, which is about dozens of acres, required hundreds of workers laboring for days. Today, machines can complete the same immense workload in just a single day. This replacement not only reduces costs, but also ensures consistent care, something nearly impossible to achieve with manual labor. The grapevine pruning machine is more than a production tool. It is a symbol of modern agriculture's progress, where human effort is freed from heavy labor and technology becomes the driving force behind bountiful, uniform, and high-quality harvests. Cabbage harvesting was once tied to the image of farmers bent over in the fields, cutting each head by hand and stacking them onto ox carts or carrying them to market. The work was backbreaking, time-consuming, and often left the vegetables bruised and damaged. Today, a modern harvesting line has completely transformed that process. The cabbage harvester moves steadily down the rows, its sharp blades slicing cleanly at the base. A conveyor immediately lifts each crisp green head and carries it smoothly into the storage bin. As the cabbages travel along, powerful fans blow away the outer leaves, leaving only the firm, fresh, rounded heads. Thousands are handled every hour, each one processed with the same precision. By the time they leave the field, the cabbages are nearly prepped, ready to go straight to supermarkets or into factories to be turned into pickled vegetables, kimchi, or neatly packaged produce. Gone are the days of farmers straining their backs across vast fields. In their place stand intelligent machines that make harvesting faster, more uniform, and more efficient. Behind every cabbage displayed on a supermarket shelf lies a modern process working quietly in the background, delivering fresh vegetables to millions of meals each day. From oranges, potatoes, onions, cabbages, all the way to vast vineyards, each type of crop now has its own specialized harvesting technology. These machines are not only transforming traditional farming methods, but also becoming symbols of a modern agriculture, one that saves human labor, shortens working time, ensures consistency and quality, reduces losses, and increases the value of every single product. This is not simply about replacing manual work. It is a strategic leap that opens the door to the future. With mechanization and automation reaching every field, we can produce more on the same area of land, reduce input costs, protect water and soil resources, and at the same time increase profits for farmers. These very innovations are what make global agriculture faster, more efficient, and more sustainable. But the journey of exploring agricultural technology does not stop here. Each upcoming episode will reveal new secrets, from smart planting techniques to managing crop diseases with data to advanced farming models right in our own homeland. If you would like to go deeper with me, make sure to follow this channel so you will not miss any episode. Because who knows, maybe the knowledge you gain today will become the key to helping you farm more effectively, run your business more successfully, and step by step create prosperity right on your own land.